Please welcome Álvaro Ibraín Rodríguez, expert data scientist at BBVA. He'll be discussing causality in retail banking at BBVA AI Factory. Please remember to use Slido for your questions, and welcome.
So good morning, everyone. I'm Álvaro Ibraín, and I'm a data scientist at the AI Factory of BBVA. And actually, I'm doing this talk on behalf of my colleague, who unfortunately couldn't come today. So maybe I don't have the answers to all of your questions, but I promise that I'll do my best. Today I'm very excited to share with you how Causality is revolutionizing retail banking at BBVA. And for those of you who don't know, BBVA is one of the most or the biggest banks in Europe and Latin America. It operates in more than 25 countries, covering a wide range of financial services. And for a few years now, it has bet heavily on AI to enhance its core operations. And that's why it created the BBVA Factory, which is our AI hub. This hub is distributed across 3 countries, namely Spain, Mexico, and Turkey. And it is composed of multidisciplinary teams comprised of ML engineers, data engineers, AI architects, product experts, and of course, data scientists. These teams collaborate to create end-to-end data products that are used to solve business needs at BBVA. And one core distinction of these teams is that they have a strong focus in innovation. Some examples of these are, for example, some prototyping programs, which are called the X programs, and also quick study initiatives that try to figure out how to include state-of-the-art or cutting-edge methods into our models and our products in order to further improve them. So, what do we actually do? Our work revolves around 3 pillars. The first one being that we want to ease the interactions our customers have with us by using AI as much as we can. The second is that we always try to use the most recent stuff, state-of-the-art methods, in order to improve the core bank and the core processes of the bank, like, for example, fraud detection or risk management. And lastly, we work for enhancing the relationship with our customers by providing them personalized experiences. So why causality it is important to us? Well, in most of our cases, we can just simply run A/B testing or randomized exploration. This is due to regulatory restrictions, technical inviolabilities, and even ethical concerns sometimes. Without those tools, causality comes as a very handy tool for us because it allows us to further understanding our models and also evaluate the effects of certain actions. And often all of this only with observational data, which allows us to draw far complex relationships between variables and thus making far better decisions. So today I wanted to share with you 4 use cases that currently are applying causality at BBVA. And within the bank there are several initiatives, or within the AI Factory, which are working with different business lines across the bank. Here are 4 of them. The first one being financial health, which is an initiative that tries to build tools that enhance the finances of our customers. For example, giving them advice on what to do with their savings, alerting them when anomalies happen, or forecasting, for example, expected movements. So the question here was to evaluate or get to know whether these tools are really useful to our customers and to what extent. The second one is the personalization program, which tries to hyper-personalize our digital channels to its customer. For example, personalizing the view of the app depending on the profile of the customer, or recommending them several financial products. The question here was regarding to whether recommending or showing a client an ad of some of our products really makes them more prone to acquiring them. The third one is risks. As you already know, we're a bank, and at the end of the day, we lend money to people and companies. And sometimes, this line tries to make tools in order to further minimize potential losses. So sometimes clients default, and we want to give them some tools in order to solve the debt problem. So in some very special scenarios, when the debt status goes really bad, the bank is willing to accept partial losses in order to avoid further potential losses of the entirety of the debt. So the question here, and it is a very particular and special question, is how much are we willing to lose in order to avoid further potential greater losses? And the last one is dynamic pricing, which is a program that builds algorithms to intelligently price some of our products. And today I'll be covering a very specific case of one product, which is our pre-graded loans. So for the financial health case, there are, if you recall, we tried to offer our clients tools for improving their finances. So here there are several problems or issues. The first one being that defining what is actually a healthy financial situation, it's not trivial. We can use proxies like, for example, total debt or satisfaction scores. The problem with them is that they often exhibit high variance. So that's the first problem. And the second is that these tools for the bank have been existing for years now, so it's currently impossible to isolate a control group. That is that's why we tried to apply causality. The idea was to compare the total savings amounts of users of these apps versus non-users of these apps. The problem is that here there is an inherent bias. So we applied techniques such as PSM or double ML, while adding correcting confounders like age, expenses, navigation features, etc., in order to correct those biases. And the results were pretty good, as you can see. We actually found a positive effect for our Spanish and Mexican users of their savings being incremented by 11% in Spain and 20% in Mexico, which is great. Regarding personalization, here we wanted to answer actually two questions. The first one being, is a client more likely to purchase a certain product once we show it to him? And the second is that we wanted to compare two versions of our recommender system. We had a previous baseline, and we have the latest version of our system. Here we have countless issues. We try to apply A/B testing. However, there are too many types of biases that damage the results. For example, we have selection biases because heavy users of the app are more likely to be treated than non-heavy users. We have attribution difficulties because lots of the products take weeks, if not months, to become purchased. So making the attribution of a conversion through a show of an ad months before, it's quite difficult, and we often find that we don't have the exclusivity of impacting the clients. There are other channels that also show ads to our clients, and that's very difficult to control for. So in order to solve this problem, we mainly applied meta-learners to study these effects, and the results were good, as we found that there was indeed positive effect to both of the questions. So that's allowed us to validate our hypotheses and models. And as a byproduct of that, we also identified a certain subset of clients that weren't very sensitive to our ads. And that's meaning that if a client was very prone to a certain product, showing them didn't matter because he was going to purchase it anyway. So we could use that space on the app to show other things. Regarding risks, if you recall, we want to answer the question of how much are we willing to lose in order to minimize future potential losses. And I must remark that this specific use case comes only from a pure research perspective, and it is not in production right now. And as a matter of fact, if this problem interests you, later this evening my colleagues Clara Higuera and Javier Moral are covering this in more detail. So I strongly recommend you to attend their session. So there are, returning to the matter of this problem, here there is a quite important restriction, that is that we cannot do random exploration, because we cannot offer or make different offers to similar clients. So that only leaves us with historical data or observational data, which is very scarce and presents, again, quite considerable amount of biases. One, for example, is selection bias, since historically similar clients were offered a similar percentage of condonation. So we have to follow a rigorous debiasing process, and with that we managed to learn a causal graph and train an edge learner to do causal inference in order to produce counterfactual estimates for new clients. So this is an example of something that wasn't previously possible, and causal inference enabled. Lastly, regarding the dynamic pricing program, if you recall, we wanted to focus on the question of how much can we lower the prices of our pre-granted loans in order to drive demand up while avoiding losing revenue. So here, after applying several debiasing techniques, we were able to model the demand curve for a given price and a given risk score using those two models, the Probit and the Tobit one. And the results were also very positive, as we could drive our prices down, stimulating demand and also increasing our revenue. So as a summary, Causality is a very important tool that helps us not only understanding what is happening, but more importantly, why it's happening. And it offers several benefits for financial institutions or banks. I have put 4 of them here, which in my opinion are the most important ones. The first one being that in a heavily regulated industry like ours, it is crucial to meet legal standards and sometimes even go beyond them. So knowing the effects of our actions makes us able to move faster while staying compliant. The second one being that every day customers want more and more personalized experiences. So if we can estimate the effect of doing certain actions, we can drive the responses of the clients, and we can further tailor more personalized experiences to them. The third one is, as I mentioned before, having the ability to estimate the effects of our actions makes us able to plan with a further viewpoint. And that are the examples of the risk and dynamic pricing, which, as you know, allow us to maximize long-term goals of minimizing total losses and maximizing revenue. And lastly, as I said, we often cannot do random exploration, so it becomes a very useful tool in order to estimate the effect of our hypothesis and our models. And recall that in the 4 previous examples, only one of them used A/B testing, and even with that, it was not enough. So what's the future for us? Embracing causality, it's not just a technical issue, it's a cultural change. And it has certainly added a more scientific point of view to our decision-making processes. Innovation is one of our core missions, so we are still studying what more cases could benefit from causality. And with the bloom of Gen AI technology, more and more use cases within the bank arise every day. So we are already exploring the intersection of these two fields with the aim of finding causal relationships between large amounts of unstructured data. We also see causality playing a critical role in regulation because it allows us to further understand the impacts of automated decision making. And as for the future, BBVA will, we are going to push forward the causal mindset within the organization and include it in more and more of our use cases. So thank you very much for your attention.
Amazing. Thank you very much. We do have a lot of questions, Álvaro,
Wow.
but we don't have a lot of time.
Okay.
So I'll do the top 2, and then feel free to grab Álvaro wherever you see him lurking around the building. First question is, in your personalization case, is causal AI making the bias risk more likely? Maybe using sensitive features like gender, faith, political views, etc.
We actually, in most of our use cases, cannot use sensitive information such as gender, sex, or so. We're mainly using navigational features and also features like balances or everything that describes the behavior of the customer in a financial way. Regarding this question, those features don't matter.
Amazing. Final question. How do you determine which estimates are better when there's no ground truth?
Depending on the case, we usually rely on domain expertise for some cases. In other, we apply several evaluation techniques like gain curves or the evaluation of the counterfactuals we get.
Amazing. Thank you very much, Álvaro.